So we're going to take a look at the primary trig ratios. And this is something that you would have done back in grade 10. You would have been first exposed to it then. And basically, when we're looking at a ratio is a fraction. It's a relationship between the length of one side of a right angled triangle with the length of a different side of a right angled triangle. And there's three primary trig ratios. One is the sine ratio, the other is cosine ratio, and the third is the tangent ratio. Okay, and so we can remember these three ratios using the expression SOHCAHTOA. And so when we look at the sine ratio, what it means is that the sine ratio of any angle, that's what sine of x is, and x in this example is going to represent some unknown angle. So the sine of any angle is equal to the length of the opposite side divided by the length of the hypotenuse. And on your button, on your calculator rather, there's a button called sine or SIN. And then you also have the cosine ratio, which is the cos of any angle is equal to the length of the adjacent side divided by the length of the hypotenuse. It's got the cos button on your calculator. And you also have the tangent ratio. The tangent ratio is tan of x, or the tangent ratio of any angle, is equal to the opposite side length divided by the length of the adjacent side. And again, on your calculator, you have a button called tan. And to remember these three things, we've got the expression SOHCAHTOA. So the first three letters is for the sine ratio. So sine of any angle is equal to the opposite divided by hypotenuse. S is equal to O divided by H. Cosine is equal to cosine ratio of any angle is equal to the adjacent divided by hypotenuse. And the last third there is the tangent, or the tangent ratio of any angle is equal to the opposite divided by the A, or the adjacent value. Okay, so anytime you're working with SOHCAHTOA or you're working with trigonometry in general, you've got to make sure that your calculator is set in degree mode. Most calculators have a button along the top row that looks like either DEG or DG or DRG up at the top, and so when you turn your calculator on, it should indicate that it is in degree mode. And if it's not, if it's in a mode called radians or a mode called gradients, you're going to get wildly different answers than what you should be getting. So you need to make sure that your calculator is always set in degree mode. So let's take a look at a couple of examples that we have here. So we have one triangle that we're going to start working with here. So in this case, we're looking at angle P. So for angle P, what we want to do is we want to recognize where angle P is. Well, we know that angle P is right in there. Okay, and angle P is what everything is relative to. Okay, so when we go through and we're finding the sine, cosine, and tangent ratio, we need to understand what it is for angle P. Okay, so as we look through this, we want to recognize that first thing we got to do is label this triangle. So our right angle is right here. So in this section here is where we actually have our hypotenuse. Okay, that's our hypotenuse. Because we're looking at angle P, our opposite side is actually down here. Okay, and so this is our opposite, and that means that this side is our adjacent side. Okay, so because we have those three sides, we've been able to label the triangle with our HOA. We can go forth and we can actually identify what the relationships are between these things. So let's start firstly by taking a look at what is the ratio. Okay, so sine x is equal to the opposite divided by the hypotenuse. Cosine x is equal to the adjacent divided by the hypotenuse, and tan of any angle is equal to the opposite divided by the adjacent. Okay, so that's what we're trying to figure out all the way around. Okay, so if we're looking for sine of angle P, because we're looking at angle P here, that's what we're focusing on. So we've got sine of angle P, cosine of angle P, tangent of angle P. So we're going to just substitute in values that we have here. Okay, so we know that for each one of these, it's going to be the length of one side divided by the length of the other. Okay, so for sine of angle P, sine of any angle is equal to the opposite divided by a hypotenuse. So in this case, we know that our opposite is 9, and our hypotenuse is going to be 15. For our cos of P, we know that it's the adjacent divided by the hypotenuse, so the adjacent here is 12, and the hypotenuse is again 15. If we then look at the tangent ratio for angle P, tangent is our opposite divided by our adjacent. So our opposite is 9 units, and our adjacent happens to be 12 units long. Okay, so now we've gone through and we've identified what these are. Now we can continue and we can put these into lowest terms. So 9 over 15, both of these numbers can be divided by 3. So that's the same as 3 over 5. If we look at cos of P, we can put this into lowest terms as well. 12 over 15, both 12 and 15 can also be divided by 3. And that's going to actually give us 4 over 5. And same thing with tang of P. So it's equal to 9 over 12. 9 over 12 in lowest terms. Again, both those numbers can be equally divided by 3. That'll give us 3 over 4. Okay, so in this instance, we are able to identify what the ratios are between those different side lengths. Okay, if we look down a little further, we've got a second example that does much the same thing. Okay, in this case, we're actually looking for angle Q. We're trying to figure out this angle right down there. Now, just let me quickly correct these. These all should be for angle Q, because we did angle P up top. Okay, and again, we're going to follow the same process. First thing we always need to do is we need to label our triangle. So in order to label this triangle, you always want to start with where the hypotenuse is. Well, the hypotenuse is across from the right angle, so this is still our hypotenuse. It's the longest side of the triangle. We want to label our opposite side. Well, now because we're looking at angle Q, the side opposite of angle Q happens to be 12. Okay, and then finally the last piece is going to represent our adjacent side. Okay, so again, we want to identify, well, what are the actual primary trig ratios? So sine of any angle is again equal to the opposite divided by the hypotenuse. Cosine of any angle is equal to the adjacent divided by the hypotenuse. And the tangent of any angle is equal to the opposite divided by the adjacent. Okay? So now if we go through and we substitute in our values in for what we know in terms of angle Q, we know that the sine of angle Q is going to be equal to the opposite, which is 12, divided by 15. We know that the cosine of angle Q is going to be equal to 9 divided by 15. And we know that the tangent ratio is going to be equal to 12 divided by 9. Okay? Now again, we can put all these things into lowest terms. So in lowest terms, we're going to end up with 4 over 5, because both can be divided by 3. Here we're going to end up with 3 over 5. And finally over here we end up with 4 over 3. Okay? So as we've gone through, we can identify what our primary trig ratios are, okay, using SOHCAHTOA. And we can figure out what the value of that ratio actually is.